right, folks, so Mountain Math was turned in. Today you're going to have another worksheet for homework. Make sure you ask me questions because most of your worksheet's going to be done via Desmos. Okay, so make sure you ask questions. We're not on Desmos now. I got some vocab to do, so there's no reason to be kind of messing with your computer now. What are we talking about today? Scatter plots. What is a scatter plot? Yeah, guys, you understand when you collect data, it's not all like nice and neat and perfect. Does it ever end up in a nice, perfectly straight line? No, okay? So that's why we call it a scatter plot, because it is kind of scattered all over the place. So a scatter plot is a graph of data. Okay? In fact, it's called bivariate data. Guys, what does the prefix bi mean? Two. So what do you think the word variate means? What does it sound like? Variate. What does it sound like? Variable. Variate, variable. They sound similar, don't they? Okay, so bivariate data is with two variables. Now, folks, this should make complete sense to you because if I have a graph, you have to have an x and a y, don't you? Which is two variables, isn't it? Okay, so it should make sense that I'm calling this bivariate data. And then we have something called correlation. Do y'all see my pictures down here of correlation? Looking at those pictures, what do you think correlation is? What do you think, Savannah? Yes, I'm going to use a different word besides direction and order. I'm going to call it a relationship. Okay? It shows a relationship between the variables. A relationship between the variables. Are you writing this down? I'm sure somebody in here has got something you can write with. Guys, how many choices do I have for correlation? 3. What's the first choice? Positive. Folks, if it's positive, what is it doing? It's going up. And notice I have this underneath here. So I want everybody to take a look here. It says that x increases. Folks, if x is increasing, which way am I going if x is increasing? To the right. So as I go to the right, as x increases, what do the y's do? They go up. They increase. Now, this is a typo. I need you to fix this for me. Because as x increases, what is the y doing? It's decreasing. Do you see how that's going down? It is trending downwards. The relationship is negative. It's going down. And then we have the last choice, which is what? There is no rhyme or reason to that data. Do you see how it's just really all over the place? It's not going up. It's not going down. It's pretty random. Okay? So does that really show me any kind of a relationship there? No. All good with those definitions? Okay, so I believe I have 3 graphs down there for you. Are they all scatter plots? They are. I want to know what the relationship is, and then I want you to describe it. So take a look at the first one. Is it positive going up, negative going down, or none, it's everywhere? It's positive. So you're going to tell me that the relationship is positive. Then you need to describe it to me. In this situation, well, if you look at the graph, across the x, we have years. Across the y, we have travelers. And you see it's international travel, correct? Okay, so going this way means my x's are increasing, correct? So are the years going by? As time goes by, what happens to the travelers? It increases. So as the years pass, number of travelers increases. So you're not just going to tell me it goes up. You actually have to put it into the context of the problem and describe what's happening. Number 2, positive, negative, or none? Negative. Describe it to me in this context. What's across the x's? So as years pass, students per computer decrease. Okay, now guys, this should also make sense to you. Think about it. 5 years ago, did you have your own Chromebook? We had carts, like one cart per building, and you had to share it, didn't you? Okay, so now everybody has their own computer, which means students per computer is decreasing. Right now, we got like one computer for one student, don't we? It used to be like 5 students per one computer. Make sense? Yes. The only kids in this district that don't have their own personal Chromebook is the elementary. Everybody else has their own personal Chromebook now. Okay. Yeah, they just don't get to take them home, but they get the same Chrome, like it has their name stickered on it. They just don't get to take them home. What's up? Close. I think it's like 2 to 1, but they're still in carts and they still share them. Like, so yeah, it's pretty. Yeah, it's pretty impressive. My kindergartner works on a Chromebook, which is crazy. Their Chromebooks sold for kindergarten are the touch Chromebooks. So like you could actually touch on your screen. Uh-huh. Uh-huh. What's that? When do they go to school? Oh, right here at the elementary. My kids go here. Yeah. Yeah. What's up, Brayden? Uh-huh. Every day. They have to turn it in. At the end of the day, they pick it up in the morning. Mm-hmm. Correct. They're expensive. I don't think I would trust a 6th grader to transport a Chromebook to and from school, right? Okay, last one. Positive, negative, or none? I get a lot of people that say none, but it is not none. It is going down. Okay, this is negative. Can you describe it to me in this context? No. What's the height doing? As height increases, three-point percentage decreases. And again, this sentence should make sense to you. Do big guys shoot the 3 very good? Very well? No. The taller you are, typically the worse a 3-point shooter you are. Typically. Well, Seth Curry is still pretty tall. Or Steph Curry's. He's still 6'3", but in the NBA, that's really short. I think average NBA is like 6'6", 6'7". Yeah. Crazy. Correct. But Mike Tyson is one of the greatest athletes. Yeah. It's crazy. He did do that. Yes, you are correct. All right, folks. So now we're going to make our own scatter plots. Okay. So go ahead and flip your paper over. You see up top it says a line of best fit. We're going to draw a line of best fit. It is a trend line used to make predictions. A trend line used to make predictions. So if your correlation is positive, which way should your line probably go? Up. And if it's negative, your line will go down. Folks, if there's no correlation, you can't draw a line because I don't know if it's going up or down because it's just all over the place. Make sense? Okay, you have data there. We need to plot this data. What's your first set of data? 0, 5.08, so maybe around there. You're just plotting your data. Second point is 1, 539. Okay, you should be able to graph this just fine without looking up here. You should have no problem graphing this. 2, 566. 3, 5.81. And 4, 603. Okay, now, make sure you got all those points on there. Is this a nice, perfectly straight line? It is not. And it shouldn't be because it's a scatter plot, yes? looking at this thing, would you say it has positive or negative correlation? So your line should go up when you draw a line, correct? I'm going to tell you the 2 points to go through for your line. Are you ready? Y'all have your straight edge? Okay, I want you to go through 1, 539 and 3, 581. Use your straight edge and make yourself a line that goes through there, please. That is my line of best fit. So for the next couple days, when you guys come in here, you need to grab a straight edge because we're going to be using them. Just like it says on the board, you're supposed to get a straight edge. It can be a library card for all I care. That's what my 8th graders use, is their library cards as a straight edge. Okay. Yep. How we doing on our line of best fit? If it's a good line of best fit, it will go right through the data. Will it touch all the points? No. Now, letter C says write the slope-intercept form of an equation for the line of fit. Guys, what's slope-intercept form? So, in the past, for the past week or so, what 2 things did I have to find? Did I have to calculate? So I would have to do y2 minus y1 over x2 minus x1, correct? And then I'd have to plug it in to find the b, yes? We're going to make Desmos do all the work for us, as long as you can follow my directions. Are you ready? Okay, so I told you what points to go through, yes? If it were me, I would star it by your table, so you know what 2 points we're using on your table. So right next to your table, I said 1, 539, right? Star it. And then what was it, 3, something? Star that. Okay, let's go to Desmos now. All right, do you see the plus sign up in the corner? Hit that plus sign, please. Select table. And now we're going to enter in the points that I told you to go through. What were those 2 points? 1, 5.39. Now notice, it put me a dot right there on my graph. Does everybody see that? What's my second point? 581. And there's my second point on my graph. Here's where I need you to raise your hand if you don't have 2 points on your graph. Because the next thing I'm going to do is make a line go through them. Are you ready? Yes? You agree that a line is written in y equals mx plus b, correct? Well, here's the catch with Desmos. Do you see how above your chart it says x1 and y1? So instead of using just x and y, I have to use x1 and y1. Is everybody clear on that? The only other difference is instead of an equal sign, you have to use this squiggly bar right here. That means approximately. Because folks, are all of my points going to be on this line? No, so I can't use an equals bar. I have to use approximately. It is directly underneath your escape key on your keyboard. Does everybody see it? Yes. Okay, so here's what we're going to do. We're going to click on the next box underneath here in Desmos. Next box. And we're going to type this in. Now I need you to be careful and make sure we know how to do this, okay? So enter in a y. But now I got to put a sub 1, don't I? You see how there's a 1 down there? You're going to hit your ABC button. Pay attention, folks. I don't want to go through this 15 times, okay? Hit your ABC button down here. And you should see this sub button. Do you see how it's A sub B? You're going to hit that, and you're going to type in a 1 for y sub 1. Then you're going to hit your over key to get out of the bottom, okay? Hit your over key, and here's where you're going to hit that approximately button. You're going to have to push shift, and then hit that squiggle bar. How we doing, guys? Do you have this in your computer right now? Now we're going to type in M, X, and now I need another sub 1. How we doing? Get out of the sub by pushing your over arrow, and then put plus B. And it should make a line appear on your graph. is, if you look, you see how it tells me what the M is? And it tells me what the B is. So all you have to do now is go back to your paper and write this in y equals mx plus b form. Okay, so go back, and here's where I'm going to need somebody to read this back to me, okay? Y equals, and there's your equation. Pretty awesome, right? No, it's a real life situation. Yep, real life situation. How we doing here, guys? Can you recreate this, you think? I hope so. You better write down this. Whoops, you better write down this because you're going to need to be able to create that on your own. Put it somewhere on your paper so when you do your homework tonight, you have it. All good? Are we ready to try again? Great. Next one. I'm pretty sure all of the points are put on that graph for you, correct? Okay, so the scatter plot is done. I want a line of best fit. I'm going to tell you to use 10, 80 and 32, 290. So can you please find those data points on your paper? 10, 80. Find it. There should be a dot there. 10, 80. Should be right there. Everybody see it? 32, 290. 32, 290. Does everybody see that dot? Draw a line through them. That's going to be your line of best fits. Once you draw your line through them, we're moving on to part C. Write the equation of a line in slope-intercept form. Well, slope-intercept form is this. Desmos will do it for me if I enter those points. Now, the good news is, folks, you already got all this stuff pretty much entered into Desmos. All I got to do is change out my x's and my y's, right? Okay, so what am I going to put in here for my x? Say it again. 10, 80. And then what was the other one? 290. And you're probably going to have to zoom way out. Oh, that says 5290. 290. Because 290 is a pretty big number. So you're going to have to zoom out. How we doing? Oh, I only got 1 point. Where's my other point? Keep going. There it is. Does everybody see my 2 points? 80. 10, 80. Actually, I probably can zoom in here. How are we doing, guys? Fine? Okay, so we're done, right? What is the equation of this line? Now, I'm going to tell you I want 2 decimal places, okay? 2. Round appropriately. So this says 9.54, doesn't it? What's after the 4? So this is going to round it up to 9.55. Okay, so let's go back here. Y equals 9.55x. What's my B? 4, 5. What's after the 5? A 4, so it's going to stay a 5. Now, guys, you should make sure that this line makes sense. Where would you be beginning this line? Does it look like your line would cross down here in the negatives? Yes. So we're good to go. But there is a part D to this, folks, and you will be asked to do this in your homework as well. It says predict the number of calories burned for 55 minutes of exercise. Minutes. Is that an X or a Y in this problem? It's down here. It's an X, isn't it? So what am I going to do with that 55? You're going to plug it in. 9.55 times 55 minus 15.45. Approximately 509. Are you all getting that on your calculator? Now, again, you should make sure your answer makes sense. 55 minutes would be like right here, correct? If I follow that up Does that look like it would be on that line at about 509? That's about 509, isn't it? So we must be pretty good. How we doing? Okay. I got one more for us down there. Are your points on that graph? Okay, you plot the points, please. Go. I know, right? And I had somebody ask in my last period. Yes, 2004 is at the very end. I know it doesn't say 04 down there, but it is at the very end. What is up with this graph? It is everywhere. There is no correlation. Guys, what is this situation? Why is there no correlation in this situation? What are we talking about? Major League Baseball games and how long they are, correct? Is there any way for me to predict how long a baseball game is? Baseball games don't have time limits, do they? It's just however long it takes for 9 innings. There is no way to predict this, and that's why they are all over the place. If there's no correlation, can I draw a line of best fit? No, I can't, because they're everywhere, aren't they? So I cannot complete any more of this problem. I would stop, and I would write down there is no correlation. Okay, I cannot do a line of best fit if there is no correlation. Right? I would like to do one question on your homework with you, if that's okay. Good? It's a worksheet, so I'll pass that out to you first, and then we will complete that. So folks, I want you to take a look at this worksheet. It is broken up into 3 sections. The top part, which you see numbers 1 and 2 up there, that is you just telling me what the correlation is and describing it. Is everybody all right with that? Okay, the next number is number 3. Does everybody see it? This is the one I would like to do together. Okay, your directions say draw a scatter plot. Folks, can you please plot those points? I'm on number 3. Please plot those points. How'd you do? Do we have all those points on that graph? Okay, so it says draw a scatter plot, which we just did. Now it says determine the relationship. What do you think the relationship is here? It is negative. Can you please describe it in this situation? Perfect. As the years go by, the cases decrease. Okay, now it says draw a line of fit for the scatter plot. Now, folks, if I ask you to draw a line of fit, I have to tell you the 2 points to go through, don't I? Okay, so I'm going to have you circle 2001, 39, and 2004, 16. Then I want you to go down to your graph and find them, and I want you to draw your line of fit through those 2 points. Draw your line of fit through those 2 points. That would be part B. Part C is where Desmos comes in. I need to write an equation, don't I? Which means I got to put my points in. Now, everybody stop and look here, please. Look at this graph. This graph on the, okay, I need your eyes. This graph on the x-axis starts at 0, correct? So this is actually not 2001. What do you think the x value should be here? If this is 0, what is this going to be? 1. What's this one going to be? 2, 3, 4, and 5. That's what you are going to use when you plug it into Desmos. Are we clear? We only do that with years, okay? Because, guys, 2001 is huge, isn't it? My graph is going to be ridiculous if I do that. Those we would do it the same way because they're too big. 1999, way too big. Okay, so now I'm going to go to Desmos, and I need, this is all going to go away. Is everybody good with this? Okay, I need somebody to read back to me what my points should be. Now, am I going to use 2001? I'm going to use 1, 39, 4, 16. And I can zoom back in probably because these numbers aren't as big as my last one. How is that for everybody? Did it keep the line there for you? If it didn't, you have to go to the next box and enter this in. All right, you see those numbers there, right? Yes? Yes? Are we ready to write our line? Yeah? Let me get back here. All right, what are you going to write for your line? Y equals? And I think I'm just going to put 6 repeating. Is that okay? Because all those 6s keep going, don't they? Is that all right for everybody? Yes. Okay, how about my B? 46.6 repeating as well? How we doing with this, guys? Good? So you have the 2 to do up top, and then we also have number 4 to do down here, okay? But I need to tell you the points that you're going to use. Are you ready to circle them? I would like you to use 15, 40 and 40, 77. Does everybody understand what's being asked of them today? All right. Yes, this is our sheet here. I just need to write a couple things on it. Do you have your homework to turn into from yesterday? Your math and any makeup work at all? No, I have all that turned into. Okay, sounds perfect.